Think you know the whole story? Turns out you were probably taught the half-truth. Welcome to Half-Truths. Close your eyes for a moment. Picture a perfect storybook version of an English countryside. The grass is impossibly green, the sky a gentle blue, and somewhere a cuckoo clock is probably sounding the hour. Under a sprawling, gnarled apple tree, a man sits in quiet contemplation. He's dressed in the fashion of the late 17th century. Long coat, perhaps a wig slightly askew. He's deep in thought, wrestling with the very secrets of the cosmos. And then it happens. A single ripe apple detaches from its branch. It falls, not to the side, not into the grass, but directly, comically, and perfectly onto his head. Thump, his eyes fly open. The universe rearranges itself in his mind. The apple, the earth, the moon, the stars. It all clicks, gravity. In that one simple, concussive moment, Sir Isaac Newton understands it all. It's a perfect story, isn't it? It's the story we were all told in grade school. It's been the subject of countless cartoons, illustrations in dusty textbooks, and even commercials selling everything from computers to breakfast cereal. It's the ultimate symbol of the eureka moment, a single random event that triggers a world-changing revelation. It's clean, it's simple, and it makes the daunting concept of genius feel wonderfully accessible. An apple could fall on anyone's head, right? A flash of brilliance could strike at any moment. It's a story that tells us discovery is not the product of grueling work, but of a happy accident. But you're listening to Half-Truths, and you know what question is coming next. What if that story, the single most famous tale in the entire history of science, isn't the whole story? What if the apple on the head is a convenient, charming fiction that obscures a far more interesting and far more human tale of struggle, rivalry, and 2 decades of relentless intellectual labor? Today, we're putting on our proverbial hard hats and sitting under that legendary tree. We're going to dissect the myth of Newton's apple, and in doing so, discover what the concept of gravity really cost, and why the simple story of a falling fruit was one of the most brilliant pieces of marketing a scientific theory has ever had. Let's start by truly appreciating the story we all know and love. Because to understand why a myth persists, you have to understand why it's so compelling in the first place. The power of the apple story is its sheer simplicity. It takes one of the most complex and revolutionary ideas in human history, the law of universal gravitation, and gives it an origin story that a child can understand. Science, particularly physics of Newton's caliber, is intimidating. It's a world of arcane symbols, mind-bending mathematics, and concepts that challenge our everyday intuition. The Principia Mathematica, Newton's masterwork where he lays out his theories, is a dense, formidable book written in Latin and filled with geometric proofs that would make most of us run for the hills. The story of the apple, however, is the complete opposite. It's folksy. It's pastoral. It's a moment of pure, unadulterated inspiration. It transforms Sir Isaac Newton from a notoriously difficult, obsessive, and sometimes downright unpleasant genius into a gentle, daydreaming philosopher of nature. He's not hunched over a desk scribbling equations for 17 hours a day. He's dozing in a garden, waiting for the universe to literally knock on his head. It's a story that does what all great myths do. It domesticates the sublime. It takes the terrifyingly vast and makes it feel personal and relatable. It suggests that the deepest truths of the cosmos aren't locked away in inaccessible formulas, but are waiting to be discovered in the most ordinary of observations. This narrative is also deeply satisfying because it aligns with our cultural love for the eureka moment. We love the idea of the lone genius struck by a bolt from the blue. Archimedes leaping from his bath, shouting, "Eureka!" after discovering the principle of displacement. August Kekule dreaming of a snake biting its own tail and realizing the ring structure of benzene. These stories are powerful because they're dramatic. They have a clear before and after. Before the apple, gravity was a mystery. After the apple, the universe was understood. It's a clean narrative arc. The real process of science, which is often messy, incremental, collaborative, and full of frustrating dead ends, doesn't make for nearly as good a story. And so, this version of events became cemented in our collective consciousness. It was repeated by teachers, illustrated by artists, and referenced by other scientists. It became a powerful piece of cultural shorthand. To say, "It was his apple on the head moment," is to immediately convey a flash of sudden, brilliant insight. The story is so effective, so perfectly packaged, that for centuries very few people thought to question it. It was simply the truth. Newton sat under a tree, an apple fell on his head, and the rest is history. It's a beautiful story. It's an inspiring story. It's just not what happened. So where do we begin to pull the thread on this perfect little narrative? The first place to look is in Newton's own work. If this event was so singular, so transformative, you'd expect him to have mentioned it, right? You'd expect a footnote in the Principia Mathematica, his great book on gravity. Perhaps in the preface, "I must extend my sincerest gratitude to the apple which, by striking my cranium, initiated this entire line of inquiry." But there's nothing, not a single written word from Newton in his published scientific work about an apple, a tree, or an unexpected fruit-related head injury. For the man who detailed his work with obsessive precision, this is a rather glaring omission. The story doesn't appear in print until after Newton is an old man, a celebrated icon, the president of the Royal Society, and the undisputed titan of British science. And it doesn't come from him directly, but through others who heard him tell it. The two most famous sources are a man named William Stukely, an antiquarian and one of Newton's first biographers, and the famous French philosopher Voltaire. In 1752, decades after Newton's death, Stukely published his memoirs of Sir Isaac Newton's life. In it, he recounts a conversation he had with an elderly Newton in 1726, just a year before Newton died. Stukely writes that after dinner, the two of them went out into the garden for tea under the shade of some apple trees. Newton, then in his 80s, pointed to one of the trees and reminisced. He said that he was in the selfsame situation many years ago when the notion of gravitation came into his mind. According to Stukely, Newton said it was occasioned by the fall of an apple as he sat in a contemplative mood. Why should that apple always descend perpendicularly to the ground, thought he to himself. Now read that carefully. An apple falls. He sees it. It makes him think. Notice what's missing. The thump. The direct hit. The comedic bonk on the head that is the absolute centerpiece of the popular myth. In Stukely's account, the apple is a trigger for a thought experiment, not a physical assault. Voltaire tells a similar story in his letters on the English from 1733. He says he heard the tale from Newton's favorite niece, Catherine Conduit. He writes, Sir Isaac Newton, walking in his gardens, had the first thought of his system of gravitation upon seeing an apple falling from a tree. Again, seeing an apple fall. not being struck by one. So the earliest, most reliable sources for the story, the ones who actually heard it from Newton or his family, agree on the core element. A falling apple at his family home provided a moment of inspiration. But the part that makes the story so memorable, the physical impact, is nowhere to be found. That seems to have been a later embellishment, a little bit of narrative spice added over the years to make a good story even better. Like a game of telephone played out over centuries, he saw an apple fall, became an apple fell near him, which eventually became an apple fell right on his head. This raises a fascinating question. Why was an elderly Sir Isaac Newton telling this folksy story in the first place? This was a man who, for most of his life, was secretive, paranoid, and fiercely protective of his work. He flew into volcanic rages with anyone who dared challenge his intellectual priority, most famously with the German mathematician Gottfried Leibniz over the invention of calculus. So why, in his twilight years, is he spinning this simple, almost childlike yarn about his greatest discovery? The answer, it seems, lies in the art of crafting a legacy. By the 1720s, Newton was a living legend, but he was engaged in a posthumous public relations battle with his rivals. He wanted to cement his place in history. The apple story was the perfect tool. It located the moment of discovery firmly in England on his own family property. More importantly, it made the discovery seem like a moment of divine inspiration, a flash of insight granted to him and him alone. It subtly erases the messy reality of the scientific process and the contributions or parallel thoughts of his contemporaries, like Robert Hooke, with whom Newton had a bitter feud over the principles of gravity. The story makes the discovery of gravity sound less like a collaborative, incremental scientific puzzle and more like a singular act of revelation. It was brilliant, personal branding. And it worked. The story was simple, it was sticky, and it ensured that for centuries to come, the idea of gravity would be inextricably linked with one man and one fruit. So if Newton wasn't knocked unconscious by falling produce, what is the real story? What actually happened during the time this mythical event was supposed to have taken place? To find the answer, we have to travel back to the year 1665, and the setting is not one of peaceful contemplation, but of national crisis. The Great Plague was sweeping through London, a terrifying and deadly epidemic that forced the closure of cities and institutions, including the University of Cambridge, where a young, fiercely intelligent, and largely unknown student named Isaac Newton was studying. Forced to flee the plague-ridden city, the 23-year-old Newton returned to his family's rural estate, a place called Woolsthorpe Manor. And it's here, over a period of about 18 months, that he entered a period of explosive, almost superhuman, intellectual creativity that historians now call his Annus Mirabilis, or Year of Wonders. He wasn't just idly sitting in the garden. He was a man possessed by a furious storm of ideas. During this single period of isolation at Woolsthorpe, Newton developed the foundational principles of what we now call calculus. He conducted groundbreaking experiments in optics, discovering that white light is composed of a spectrum of colors. And yes, he began to formulate his revolutionary ideas about motion and gravity. The apple, if it was a factor at all, was not the beginning and the end of the story. It was, at best, the spark that lit a very long fuse. The real genius was not in noticing that an apple falls down. Humans had, of course, noticed that for millennia. The profound, world-changing leap of imagination that Newton made was to ask a much bigger question. He looked at the apple falling from the branch, and then he looked up at the moon hanging in the sky. And he asked, if this force, whatever it is, can pull an apple from a tree, does that same force reach all the way up to the moon? And if it does, why doesn't the moon fall down to the earth, just like the apple? That is the true eureka moment. It's the realization of universality. The idea that the humble, terrestrial laws of physics that govern a falling apple are the very same celestial laws that govern the orbits of the planets and the moon. This was a radical departure from 2,000 years of thinking, dating back to Aristotle, which held that the heavens were made of a perfect, unchanging substance and followed entirely different rules from the messy, corruptible earth. Newton's insight was to realize it's all one system, governed by one set of mathematical laws. The force that pulls the apple is the same force that keeps the moon in orbit. And he even answered his own question about why the moon doesn't fall down. He realized that the moon is, in fact, constantly falling. It is perpetually being pulled towards the earth. But crucially, it also has a tremendous sideways velocity. So as it falls, the earth curves away beneath it. It is in a constant state of falling around the earth. This idea of an orbit being a balance between forward momentum and gravitational pull was the key. He imagined firing a cannonball from a very high mountain. Fire it slowly, and it arcs back to earth. Fire it faster, and it goes further. But if you could fire it at precisely the right speed, it would fall towards the earth at the exact same rate that the earth curves away from it. It would never land. It would be in orbit. The moon was just a giant cannonball, forever falling. This insight was breathtaking, but it was not a theory. It was an intuition, a hypothesis, and for a mind like Isaac Newton's, that wasn't nearly enough. He needed proof. He needed to do the math, and the math was monstrously difficult. He had to figure out the exact mathematical relationship between the distance of an object, its mass, and the gravitational force it exerts. He suspected it was an inverse square law, that the force of gravity weakens by the square of the distance between two objects. If you double the distance, the force becomes 4 times weaker. If you triple it, it becomes 9 times weaker. To prove this, he needed to calculate the force required to keep the moon in its orbit and compare it to the force pulling an apple to the ground. But the astronomical data he had at the time for the distance to the moon was inaccurate. When he first did the calculations in the 1660s at Woolsthorpe, the numbers didn't quite match up. They were close, but not perfect. And for Newton, close wasn't good enough. So he set the problem aside for nearly 20 years. Let that sink in. The story of the apple suggests a flash of insight that immediately solved the problem. The reality is that he had the core idea as a young man, but the puzzle was so difficult that he shelved it for 2 decades, turning his formidable intellect to other things like alchemy and theology. It wasn't until the 1680s, prompted by a visit from the astronomer Edmund Halley, the man Halley's comet is named for, that Newton returned to the problem of gravity. Halley and other scientists like Robert Hooke and Christopher Wren were wrestling with the same questions, but they couldn't find the mathematical proof for their ideas. When Halley asked Newton what kind of path a planet would take if it were pulled towards the sun by an inverse square law force, Newton casually replied that he had calculated it long ago and the path would be an ellipse. Halley was stunned. He begged Newton to publish his findings. Spurred by this, and by his burning desire to prove his intellectual superiority over rivals like Hooke, Newton finally dedicated himself to the task. He spent 2 years of intense, obsessive work, often forgetting to eat or sleep, to write his masterpiece, the Philosophiae Naturalis Principia Mathematica, or Mathematical Principles of Natural Philosophy. The book, which laid out his laws of motion and the law of universal gravitation, was finally published in 1687. It was the culmination of a lifetime of thought, not a single afternoon in a garden. So we travel from a simple, charming myth to a far more complex and impressive reality. The story of the apple on the head is a half-truth. Was Newton at Woolsthorpe during the plague? Yes. Was he thinking about gravity? Yes. Did he see a falling apple that helped crystallize his thoughts on the matter? It's very likely he did, and he certainly thought it made for a good story later in life. But did it fall on his head and instantly grant him the fully fermented theory of universal gravitation? Absolutely not. That part is a myth. And correcting this myth matters. It matters because the fable of the apple, as charming as it is, does a profound disservice to the nature of genius and the reality of scientific progress. It perpetuates the dangerous idea that great discoveries are effortless, that they are gifts from the heavens rather than the hard-won spoils of intellectual warfare. The real story of Isaac Newton's discovery is a testament to something much more powerful than a happy accident. It's a testament to the power of sustained curiosity, of asking not just what, but why. Why does the apple fall? And why doesn't the moon? It's a testament to the necessity of intellectual humility, of being willing to set a problem aside for 20 years until you have the right tools and data to solve it. And most of all, it's a testament to the sheer, grinding, relentless work that true understanding requires. Newton didn't just have an idea. He built the entire mathematical framework of calculus to prove it. The sanitized story of the apple erases all of that effort. It obscures the struggle, the frustration, the rivalry, and the decades of meticulous thought that were the true price of his discovery. The real story isn't about an object simply falling to the ground. It's about a human mind, through sheer force of will and intellect, reaching out to grasp the very mechanics of the heavens. Now you know the real story. What other half-truths are still out there? If you enjoyed this episode, please subscribe, leave a comment, and join us next time. Until then, stay curious.